AHR-160 class, we're back with another lecture video here. We're talking about the evaporator this time. Now the evaporator is the coil in the system that actually does the cooling in an air conditioner. It's the part of the system that does the cooling inside of your refrigeration unit. So we've got some cold refrigerant in here. The cold refrigerant has to absorb heat from the surroundings, and here's how it's going to do it. In the evaporator, we're going to find the entrance to this evaporator, which is right here. So we're coming into our evaporator actually from our metering device or expansion device, depending on which terminology you use. So we've got our metering device, we got refrigerant coming out of that and entering our evaporator. Now it's important to point out that this mixture here is actually a 75-25 liquid vapor mix. So 75% liquid, 25% vapor. Anytime refrigerant comes through this meter device, there's a lot of friction imparted on it, and that's just going to tear some vapor away from the liquid, and it's going to create what we call a flash gas, and that's what it's calling it there. You see flash gas pop up several times in this PowerPoint. It's a very common term in the industry we use for that. So we got flash gas going in, liquid vapor mix. It's extremely cold. It's been rapidly depressurized by the metering device. So there again, extremely cold, ready to boil off. As soon as it comes in contact with any heat, it's right on the cusp of its boiling point. So any additional heat that it can pick up, it's going to boil off. It's going to try to pick up as much heat around from its surroundings as possible as it boils off. Let's traverse through this evaporator real quick. So we've got a 75-25 liquid vapor mix coming in. We can see a little bit more vapor than liquid happening as we go through it. A little bit more vapor than liquid, a little bit more vapor than liquid, and eventually we're going to see right here at this last green dot, there's no liquid left. Everything from there forward is vapor. That's the point. That's an important point here. Now, I don't like the way they've actually depicted this particular evaporator. What I want to do is take it and flip it over and show you that in all evaporators, the vapor comes out of the top of it. It has to be the top. Because if it's not the top, then liquid can just sort of run out of it into the suction line. So we need to take it off the top of our evaporator so that we get nothing but vapor out of it. But once it hits this point right here, once it hits this point where there is no liquid left, if there's no liquid left, that means it's a 100% vapor, correct? Now 100% vapors have a property, and that property is superheat. Once it becomes a vapor, every degree above its vapor or into its vapor state it gets is a degree of superheat. So using water for an example, if it becomes steam at 212, steam at 213 would be 1 degree superheated, steam at 214 would be 2 degrees superheated, steam at 220 would be 8 degrees superheated, and so on. So for every degree of temperature it is above its boiling point, it's a degree of superheat. Superheat is evidence. Superheat is evidence that our vapor is indeed a vapor, 100%. Has no liquid in it. If it has liquid in it, it gets back to the compressor. The compressor's not going to like that too much. Okay. First symptom of compressor liquid intrusion is bearing washout. Over time, that causes damage to the compressor in the bottom end of it. Another symptom, if we get enough liquid back to our compressor, liquid gets into the compression mechanism. The compression mechanism can't compress that liquid. So it's either going to A, tolerate it, or B, it's going to destroy itself. So you never know. It's just cheap insurance to always have a vapor going back to your compressor. And that's one of the main things these systems are designed around. So I hope you enjoyed this video. I hope you learned something from it. We're talking about the evaporator. The evaporator is part of the system that onboards the heat into the system. It sends it over to the compressor. The compressor then forwards it to the condenser where that heat is then gotten rid of, and the condenser is outside. So that's where we get our refrigeration effect, our air conditioning effect. We're just transporting heat from a place where we don't want it to a place where it makes little or no difference. Again, hope you enjoyed this video. We'll see you in the next one.